I want to test my sound first. Right. Search. First. Yeah. I want to check my voice first. Paste. Hello. I mean, the microphone quality is not that good, so I think I'm okay with that. Uh, let's check the increase the value. Now let's check the wait. I can reduce reverb sound. Let me try to check my voice again. Right. Oh, this is a lot better. Okay, let me see the CPU usage. I use 16% of my VRAM and not that much on my CPU. Let me see the stream settings. And okay, mainly use NVIDIA processing, and it's not looking so bad. I'm doing the live stream. Let me get the right posture. Okay. Greetings. Good afternoon. This is gonna be part of my journey to get my first job. And I want this channel to be the record of my journey. The reason I want to build this is I want to have more responsibility in what I'm doing. Right now, I'm so lazy. I'm having this problem that I cannot get anything done. All of my projects, I always got lazy before it even finish, even the prototype. So it's just thing like I should be more strict about myself, my routine, my doings, and that's why I came up with an idea of doing live streams. The purpose of this live stream is not about having people watching my streams, but to record my journeys, my learning sessions, to track my progress. So I think that's it. What I should do next is let's go straight to the topic of today. Is that let me set up the workspace first, and then I'll show you guys for a minute. Oh, before anything, I should check the comment section. It should notify me sound when someone is commenting on my live stream, even though it wouldn't be any people to watch my stream. But I think it's a good practice is if someone ever wander in my live stream. Let's go with hello world. Hello world. Hilarious. Okay, I heard a chat notification sound. Okay, see the comment, see the notification sounds. That means that I don't need to track of what the comment section the live stream is. I'm just going to put all of my focus on what I'm going to learn today. It's great. Let's see here. See this one? It's on this comment section, and I will put it around. This play is not bad. I mean, I should put it here. This is comment section, and we put more programs here and here. Okay. So what I'm going to learn today is let me see, browsers or window capture. Yeah, this one. Just gonna capture this one. Is it? Okay. This is mine. So today is I don't like. Let me config my screen first. Okay. I just want it to be screened here. Put it on lowest. Okay. Here I can see my screen now. Lock it. Lock it. Okay. So today, what we're gonna learn is Go language. Wait. I do need to I think this one is not a great practice. Let me just config my window position again. See what we can do. Okay. Too large. Let me remove that. Let me one capture. So we start. Let's change the song. wondering if I can change my thumbnail. I think I changing the thumb correctly, but I'm not sure. Let me check on my phone. It is working. Okay, this is working. And let's go on what we were going to do. And today I'm going to learn some Go language basics. What I already know is I already installed Go language on my machine. If you look at here in this page, you see that it has the manuals of like how to install the Go language on different operating systems. And for me, I already managed to do that. If I type Go version here, you'll see that it shows the Go version. Alright, so what I already do is the greeting and hello module. Let's review what I have learned from the last session. First, when you're doing some code project, you need to make it on like make a new directory, and then in that directory you have to type go mod init command to initialize your module. And basically in like Go language, you are working with module, and when you create new module, you have to build it on like new dedicated directory. And to build like basic module, I mean like the base of the default module, you need to use the go mod init command. This one, let me try it on here. If I create new directory named taste, and then here you say that go mod init example hello. Wait. Oh no. Okay, if I typed, okay, I created taste, and see that we need to go inside the test directory, and we use go module init to initialize, and then we give it a name. The convention of the module name is used like this. So the first part is the module path according to this documentation. Okay, the module part will typically be the repository location where your code source codes will be kept. The module path might be github.com/mymodule. So the first one is gonna be like your location. It could be the URL. So you can just, for the purpose of this tutorial, we can just use example. When I type here, create the new geo.mod, the module file, and if you look into it, this directory now have one new file. Let's take a look. So if we don't use this command, we can just have the go.mod file in your custom directories, and you put the name of the module, and you put the go version here. But because we have the command that does automatically do that, we don't need to manually create this module file every time we build a new module. Am I explaining it correctly? I don't know, but I think that's okay. So okay, let's see that to declare to have a simplest program, which is hello world, you would need a, let's go on here, see, oh no, this is not the correct one. Okay, let's look on the tutorial. See here, package main. Package is a way to group functions. It's made up of all the files in the same directory. Import the popular FMT package, which contains functions for formatting text, including printing to the console. So we need, in our main program, I think we need to package main. So our main, so it's I think it's like a C++ where you need to like specify the main function that everything of the program will start here, and the FMT is like, in C it would be equivalent to the include stdio in C, and in C++ it would be IO stream. So to run the code, we just go run and the current directory or any, I think, and this command, I think it will read the gold of module file and then scan every file in this directory until it finds the main function. Okay. So, and then this section in with go will try to teach you, like, this is a way to work with external package in Go language, and when you need your code to do something that have been implemented by someone else, you can look for a package that has functions you can use in your code. So imagine like someone would have already did some utility functions that you might not need to do it yourself from the ground up, and you can just use others like package. I think this is the same as library for C++, because there are some functions, some tools that we don't have to invent it by ourselves, and we can just use standard libraries and many things, so we can work around more creativity rather than building from the ground up. And this one will teach you to search for a package name here, and will teach you how to import those package into our main program, and after that we'll use the command go more tidy. So I think this one is what I'm This is the one I mean, I should say that this is a current part that I'm learning. Those previous page is what I already learned, and this one is what I'm learning. Here, so here, greetings. So they say that I create greetings, which which this one only have a function named hello, and this hello takes a name variable that is a string type, and it will return this function hello will return a string back. And this is a way to declare a variable in Golang. This one is a specific special operator in I mean expression or operator, I don't know, but this command, like this block of symbols, it tells to initialize a variable, and its type will be based on the return of based on the type of this part. So this one as printf, I think it works like C printf, but output as a string format, and this one output as a string, so the message will return as a string. So this function will return hi by the name of argument and then welcome, so it will welcome anyone. This function contains all the this module greetings contain only functions and does not have main, and you see on top of it is package greetings, which is a little bit weird. If we look into the past examples, see that why will not we put the names here main, we put here as a greetings. So I think we should be able to know that soon. So see that in Go language, a function whose name starts with a capital letter can be called by a function not in the same package. This is known in Go as an exported name. So to make your function exportable, we need to make the name of the function starts with a capital letter. Okay, yeah, this operator is a shortcut for declaring and initializing a variable in one line. Go uses the value on the right to determine the variable's type. Used fmt package. So here, as you can see, we have another module in the different directory called hello, this one. Go. We have package main here, and then we import two things. We import fmt and we import example.com/greetings. Here we would use functions from greetings by here greetings dot and hello, and then fmt to print a message. Declare main package. In Go, code executed as an application must be in the main package. So, to be able to have a program, you must have a main function, and main function must declare main package in that specific file. I think, I don't know. Get a greeting by calling the greetings package hello function. In real production, this module can find and download it. We don't need to we don't need to configure any of this in real production, because the first section of our module will specify the path which Go tools could find it and download it. For now, because you haven't published the module yet, you need to adapt the example.com so it can find the example.com/greetings code on your local file system. To do that, we shall go more edit command to edit example.com/hello module to redirect Go tools from its module path. So to use that, you can go module edit, replace, and these modules to the specific directories of this module that exists in our local path. This will override this one, and it will translate it to this path of this module. The command specifies that example.com/greetings should be replaced with these directories for purpose of locating the dependency. After you run the command, the code of my file in the hello directory should include a replace directive. Okay, as you can see in my program, it was as intended. From the command prompt in the hello directory, run go mod tidy. This one is important to synchronize the example.com modules dependencies, adding those required by the code but not yet tracked in the module. It will show that in this version. After the command completes, example.com/hello go module file should look like this. Okay, looks like mine. The command file in the local code in the greetings directory did not require daily create to specify that example.com/hello requires example.com/greetings. You created this dependency when you imported the greetings package in hello.go. The number of following model path is pseudo version number, a generated number used in place of semantic version number. To reference a published module, go mod a Go modify would typically omit the replace directive and use a require directive with a tag version number at the end. I don't need to follow this one because this greetings is not the published modules. And the command prompt in the hello directory, we need to go in hello directory, and then if it's like go tidy or module id, then we type go run this directory. We say the lady is welcome here. Okay, this one is new. Let's go on the new topics here. Okay. Return and handle an errors. Errors is an essential feature of solid code. In this section, you'll add a bit of code to return an error from the greeting modules, then handle it in the caller. This topic is part of a multi-part tutorial that begins with create a Go module. In greetings/greetings.go, add the code highlighted below. There's no sense sending a greeting back if you don't know who to greet. Return an error to the caller if the name is empty. Copy the following code into the greetings.go and save the file. So now they just import more thing here. Let me try to move this one first. No. Okay. Errors. Should say just cd and just greetings. I think when you import new, we need to go tidy, go module tidy. I think. Is it working? No, it's not working. Or it's not used. So I need to use it. So if it takes function says that we might return strings or error. This is weird. This is different from C++ that I learned from. And if no name is given, return an error message. If name equals anything, then return the and errors new empty. Is this wrong? Is this wrong in Golang? Oh, it's wrong in Golang. Sorry. And if a name was received, if a name was received, return a value that embeds the name in message. So we need to return message and new. This is pretty weird. This is now very different from like C++, you know. In this code, you change the function so that it returns two values, a strings and an error. The caller will check the second value to see if an error occurred. Any Go function can return multiple values. For more, see effective Go. The fuck is this, bro? Import the Go standard library errors package so you can use it. Errors new function. Add an if statement to check for an invalid request. For an empty string where the name should be, and return an error if the request is invalid. The errors. New functions returns an error with your message inside. Add nil as second value and successful return. That way the caller can see that the function is succeeded. In your hello.go file, handle error now, return by let's see, hello function along with non-error value has the following code in the hello.go. So you need another module block here. Then just set the properties with redefine loading log entry effects and a flag to disable time source file and line number. So it's like the throw error function in C++, I think. I don't know. It's just set prefix with greetings and set flag 0. Here, place a message. This one we will try to. Oh, we could declare it like this, two variable. Then we'll use this operator to receive it from this function, which will return two values anyway. Okay. If an error return print it to the console and set the correct. So we just simply check if error is not new, it's not null, I think, then it would pay it off. Error would have a message. Alright. If no error was returned, print the return message to the console. In this code, you can configure the log package to print command name greetings at the start with its log messages without timestamped or source file information. Assign both of hello return values, including errors, to variables. Change hello argument from lady's name to an empty string so you can try out your error handling code. Look for a non-null error value. There's no sense continuing in this case. Use functions in the standard library log package to output log faithful function to print error, stop the program. A command line in hello directory run. What the fuck is this? So run. No, it is run in hello directory. Is that correct? So return an error. That's common error handling in Go. Return an error as a value so the caller can check for it. Next, you'll use GoSlice to return a randomly selected greeting. In this section, we'll change your code so that instead of returning a single greeting every time, it returns one of several predefined greeting messages. To do this, we'll use GoSlice. Slice is like an array, except that its size changes dynamically as you add and remove items. The slice is one of Go's most useful types. You'll add a small slice to contain 3 greeting messages. Then have your code return one of the messages randomly for more on slices. See Go slices in the Go block. In the greetings/greetings.go, change your code so it looks like the following. So you can see on greetings, we include huh? Return secreting for a name person. If no name is taken, okay, create message using random format. Okay, this one is normal, but we can have more functions. Random format and messages. Message is which return a string or slash v. So a random format function that returns a randomly selected format. Originating message starts with a lowercase letter, making it accessible. Only code is on package. Random format declares a format slice with 3 message format. When declaring a slice, it can be dynamically changed. Use the mathran package to generate a random number or select an item from the slice. In hello, call the random format function to get a format for the message. Return. Then, oh, I forgot here. So instead of a here, we still have we, and then we here because the first part printf the format string. Just going to use this function run format. Value any format. And then let that go. Change your code so it looks like file. We're just include this name, or the for name is like as an argument to the hello function call, and then let it go. for build command in the hello directory. Wait, we need to change this one. Go build. Hello.exe. Okay. Install a parent package. And discover install path. List. Import statement. So write import statements like import key. It will start to use factor import statement. Export names. For example, pizza is an export names. Add is pie, which is exported from the math package. Pizza and pie does not does do not start with capital letters, so they are not exported. When importing a package, you can refer to its exported name. Any unexported names are accessible from outside the package. Run the code, notice the error message. Function can take 0 or more arguments. For example, add take 2 parameters of type int. Be right back. C syntax. Let's talk about C syntax. C took an unusual and clever approach to declaration syntax. Instead of describing the types with special syntax, one writes an expression involving the item being declared and states what type that expression will have. First, declares x to be an int. The expression x will have type int. In general, to figure out how to write the type of a new variable, write an expression involving that variable evaluates to basic type. Then put the basic type on the left and the expression on the right. Thus, the declarations int pointer p and int array a state that p is a pointer to int because p has type int, and that a is an array of int because a3 ignoring particular index value, which is punned to be the size of the array, has type int. What about functions? Originally, C function declarations wrote the types of the arguments outside the parents like this. So we need to declare the types. Again, we see the main function. We see that main is a function because the expression main argc and argv returns an int. In modern notation, we would write int main in rc argv and then some functions, some code, but the basic structure is the same. This is a clever synthetic idea that works well for simple types but can get confusing fast. The famous example is declaring a function pointer. Follow the rules, you get this. It's a function pointer that takes two argument, which is an int and return an integer. If it's pointed to a function, it's directly a function call an int. What if one of fp arguments is itself a function? So the fp is a pointer to a function that takes the first argument as a function pointer, like takes integer x and integer y that return an integer, and the second argument is integer b, which return the type of integer. That's starting to get hard to read. Of course, we can leave out the name of parameters when we declare a function. So the main can be declared int main inter. We call that argv is declared like this. So you drop the name from the middle of its declaration to construct its type. It's not obvious though that you declare something of type char by putting its name in the middle. And look what happens to fp declaration if you don't name the parameters. So fp is the function pointer that takes a function pointer that has two parameters and return int, and another argument is an integer which return an integer. Not only it is not obvious where to put the name inside, it's not exactly clear that it's function pointer declaration at all. And what if the return type is a function pointer? So this is a fp is what? Let's not return. This is what the fuck is this, bro? So inner one is this. This is a function pointer that takes an integer and then an int, which this fp is a function pointer that takes this function. Wait, a function pointer that takes this function and this argument. That is a pointer to a function that takes this as the first argument, and then the second one is this, which is a function pointer. Can construct more elaborate examples, but these should illustrate some of difficulties that C's declaration syntax can introduce. There's one more point that needs to be made though, because the type and declaration syntax are the same. It can be difficult to parse expressions with types in the middle. That is why, for instance, Ccast always parenthesize the type as in int I. Goal syntax. Languages outside the C family usually use its distinct type syntax in declarations. Although it's a separate point, the name usually comes first, often followed by a colon. Thus, our examples above becoming something like x and then colon int, p and then pointer to int, a and then array of int. These declarations are clear if verbose. You just read them from left to right. Go takes its cue from here, but in the interest of brevity, drops the colon and removes some of the keywords. So xint, xpointer int, xarray 3 ints. There is no direct correspondence between the look of 3 ints and how to use a in an expression. You gain clarity at the cost of separate syntax. Now consider functions. Let's transcribe the declaration for main as it would read in Go. Although the real main function in Go takes no argument. So function main arg int. Superficially, that is not much different from C other than change from char arrays to string, but it reads well from left to right. Function main takes an int and a slice of strings and returns an int. Drop the parameter names and it's just as clear. They're always first, so there's no confusion. One merit of this left to right side is how well it works. The types become more complex. Here's a declaration of a function variable. So f is a function that takes function that takes function that returns an integer, another integer, which this function turns an integer, or if f return a function. So this function this function takes this one and this one and will return a function, this function. Still reads clearly from left to right, and it's always obvious which name is being declared. The name comes first. The distinction between type and expression syntax makes it easy to write and invoke closure in Go. Sum is function AB, which are int, am I correct? And then return int, we just return AB, and it takes 3 and 4. Pointers. Pointers are the exception that proves the rule. Notice that in arrays and slices, for instance, Go type syntax puts the brackets on the left of the type, but expression syntax puts them on the right of the expressions. For familiarity, Go's pointers used the notation from C, but we could not bring ourselves to make a similar reversal for pointer types. Thus, pointers works like this: var p int. We couldn't say postfix that postfix conflict with multiplication, we could have used the Pascal, for example. Perhaps we should have, because perfect asterisks on both types and expressions complicate things in a number of ways. For instance, although one can write as the conversion, one must parenthesize the type if it starts with a star. Had we been given up, those parentheses would be unnecessary. So, Ghost pointer syntax is tied to the familiar C form, but those ties mean that we cannot break completely from using parentheses to disambiguate types and expressions in the grammar. Overall though, we believe Go's type syntax is easier to understand than C's, especially when things get complicated. Clockwise and spiral rules. String is an array of point oh shit. FP is a pointer to a function passing an int and pointer float, returning a pointer to a char. So signal is a function passing an int and a FP, which is a pointer to a function that takes integer that returns void. So signal is a function passing an integer and a pointer to a function that passing an int return nothing, and this whole idea, a signal is return a pointer to a function that takes integer and then return void. Okay, what is char pointer? Char method is a pointer to a char constant. How about this one? Char pointer is a constant pointer to a char. Finally, char pointer is a constant pointer to a char volatile. What? So confused. Okay, but it's okay. When two or more consecutive name function parameters share a type, you can omit a type from all but the last. Okay. Function can return any number of results. Swap functions return two strings. Go's return value may be named. If so, they are treated as variables defined at the top of the function. These names should be used to document the meaning of returns value. Return statement with the argument returns the name return values. This is known as naked return. Naked return statements should be used only in short functions, as with example shown here. For statement declares a list of variables. As in function argument list, the type is last. For statement can be package or function level. See both in this example. For declaration can include initializers per one variable. If an initializer is present, the type can be omitted. The variable will take the type of the initializer. So some errors here. Let's continue with this one. So if you declare it like this, you wouldn't need to specify the type, which is true, false, and no. You just gonna print this one. Inside a function, short assignment statement can be used in place of a word declaration with implicit type. Also a function, every statement begins with a keyword or func and so on. So this construct is not available. Go basic types are boolean, strings, int 8, 16, 32, 64, uint, then uint pointer, byte, alias for uint 8, rune, alias for int 32, complex 64, complex 128. So boolean complex value is zero values. Variable declared without an explicit initial value are given zero value. Zero value is zero for numeric types, false for boolean type, and empty string for strings. Expression T convert values V to the type T. Some numeric conversions. For int expression T V convert value V to type T. So this one F int and then F float 64 and convert this float to this one, and that's as well. So this one, this is period. Okay, you know that with my assembly. Type inference. Declaring a variable without specifying an explicit type, either by using syntax or word expressions. Some variable type is inferred from the value on the right hand side. On the right hand side, declaration is typed. The new variable is of that same typed. Type memory constant, the new variable may be an int, float 64, I missed something and I should look for it first. Okay, we don't need go by example. Choose a go tool. I think this is enough for today now. 2 hours, not bad. Okay, I will come back again around 2 p.m. I'm gonna do some lead code problems and some GitHub management also. So let's end the stream here.